Hi there, guys. Well, there's a special format in mathematics called the difference of two squares format, and it leads to the same factorization each time. Okay, and what we're talking about with the difference of two squares is something like a squared take away b squared if we write it in algebra, but likewise you could write it with numbers. You could say like 5 squared take away 3 squared. Those are two squares. There we go. We've got 5 times 5. Got that right? Yeah. And 3 times 3. We're taking away those two things. These are the difference of two squares. Okay, this is the particular format in mathematics. Okay, and we've got a squared minus b squared. Well, what is the format? What's the factorization of this? Well, it comes from multiplying out this set of double brackets. Okay, so a times by a gives us a squared. A times by minus b gives us minus ab. B times a gives us plus ab. And b times by minus b gives us minus b squared. These two terms cancel. We've got plus ab and take away ab, so that cancels each other out. Rather, adding 1 and taking away 1 leaves us with nothing. And so we're just left with a squared take away b squared. Okay, left with this, take away this, and this disappear. Okay, so if we did it backwards, right, just think about this backwards. So if we want to go from here to here, that would be factorizing a difference of two squares format. Right, okay. So let's try and do that with this question here. This might get a little bit messy here because I'm going to try and fit it on the same page. Didn't think this one through. Okay, so we've got, in this one, we've got x squared. Okay, so that's a bit like doing x squared there. Let's put that on there, right? Okay, so we're going to put x squared there. And then we've got 36 there, which is going to be, oh, look, 6 looks a bit like the b. So that's going to be 6 squared. Okay, so if I wanted to go backwards, then I'd have x replacing my a's and 6 replacing my b's. Okay, so 6 replacing my b's. Okay, and then I have factorized my x squared minus 36 by using the standard format. There we go. I've got x plus 6 and x minus 6. And if I multiply that out, I get x times x. I get 6 times by minus 6, gives me the two terms I want. But I'd also get 6x and minus 6x. And those two terms would cancel. Now, you can still do this. If you don't like what I've done there, you can still do this by the puzzle format, by saying, well, what two numbers add together to give the middle term, which doesn't exist, no lots of x, what two numbers times together to give us minus 36. Again, well, what two numbers work there? Well, we can see that 6 plus minus 6 works, and 6 times minus 6 works there as well. So again, that's another way of doing exactly the same thing. If we imagine that this is x squared plus 0x minus 36. So the same rule still works, the same puzzle format still works. It's just that this turns up so often in mathematics that this is a really common format which we're using. Let's look at another question to go through that. So let's look at, here we go, x squared minus 121. Okay, so this is question 12. That's not question 12. Sorry. X squared minus 121. This is question 11. Sorry about this. Right, okay. So we've got x squared take away 121. I've said that right now. X squared take away 121, and we need to use that format. So what was the format again? A squared minus b squared was a minus b and a plus b. Doesn't matter if you put the brackets either way round, doesn't really matter. A plus b, a minus b, a minus b, a plus b, whichever way around doesn't matter. Okay, this can go first or second. Okay, so again, we could substitute this x, the a for an x there. 121 is the same as 11 squared. I'll put 11 there, and then I can put in x minus 11 and x plus 11. There we go, we are done. Right, now these questions get slightly more interesting when you're doing things like, let's do 4a squared, let's say, and then take away 9. Okay, now you have to identify there what is your thing squared in each case in order to go to that format that we're using. So we've got here 2a all squared. 2a times 2a is 4a squared. Take away 3 squared. So those are the two squares that we need to identify. So now we can replace our a plus b and our a minus b, either way round. Doing it a different way round this time, doesn't matter. 2a plus 3, then we're going to do 2a minus 3. That's just the things inside the brackets. 2a at the start, and then the 3 at the ends of those brackets as well. Okay, let's do one more. Let's do a slightly more complicated one again. Let's do 169y. Oh, let's do a really complicated one. Y squared w to the 4. Take away. What can we take away here? 196. And then let's leave it like that. Okay, that's hard enough. Okay, so we'd need to identify what's being squared in each case. So that's obviously going to be quite difficult. If you want to stop this up and try it yourself, then go ahead. 196, 14 squared. 169 is 39 squared. Y squared is just y squared. And then w to the 4 is w squared squared. That's one of our laws of indices there. If you have a power on a power, then we times the two things together. So we've got w squared, and that's all squared. In other words, if I did 13y times w squared times by 13y w squared, I end up getting 169 y squared w to the 4. Okay, right. So there's a minus in there. That's the same as that. Now we can use our format. We can say we've got 13y w squared plus 14 and 13y w squared minus 14 in the bracket there. Now that is factorized fully, I think. Yeah, it's factorized fully. Okay, guys, that's good. We're done with that. Thanks for listening in. Hopefully that was useful. Let's just recap the format for the last time. If you can see, you've got something squared, take away something squared, a plus b times by a minus b, or likewise a minus b times a plus b, either way around. Okay, thanks for listening in, and have a go at this exercise from Corbett Maths. That would be a good thing to do.